Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the instruction set of 8051 microcontroller. In that video, we have seen the logical group instructions. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the data transfer group instructions. This group of instructions moves data between registers, memory locations, and input-output ports. It does not affect any flags. There are mainly three types of data transfer group instructions, such as internal RAM instruction, external RAM instruction, and program code memory ROM instructions. Let's see one by one. The first one is internal RAM instruction move. Instruction syntax is move destination byte comma source byte. Its function is move byte variable. There is no flags affected in this type of instructions. It copies the content of the source byte into the destination. Let's see the first case, accumulator as a destination. The first addressing mode is register addressing mode. Syntax is move a comma rn. That means the content of register rn is copied into the accumulator. For example, move a comma r3. The content of r3 is copied into the accumulator. The next instruction is move a comma direct. That means whatever the data is stored in this memory location is copied into the accumulator. For example, move a comma 30h. That means whatever the data stored in 30h memory location is copied into the accumulator. The next addressing mode is indirect addressing mode. Move a comma @ri. Here ri means r0 or r1. The function is the content of the data which is pointed by the register ri is copied into the accumulator. For example, move a comma @r1. That means r1 is used to point out the data in the memory location, and this data is copied into the accumulator. The next addressing mode is immediate addressing mode. That means its syntax is move a comma immediate data. That means this data is loaded or copied automatically or instantly into the accumulator. For example, move a comma immediate 25h. That means 25h, this data is copied into the accumulator. The next case is register as an destination. The first instruction syntax is move rn comma a. That means the content of the accumulator is copied into the register rn. For example, move r4 comma a. That means the content of the accumulator is copied into the r4 register. The next instruction syntax is move rn comma direct. That means the content which is placed at this memory location is copied into the destination register. For example, move r7 comma 30h. That means the data which is placed at the 30h memory location is copied into the r7 register. The next syntax is move rn immediate data. That means the data given is directly copied into the destination register. For example, move r2 comma #25h. That means this 25h is directly copied into the register r2. After this instruction, the register r2 has the value 25h. The case third is memory as a destination. The first syntax is move direct, A. For example, move 40h, A. That means the content of the accumulator is copied at the 40h memory location. The next instruction syntax is move direct, Rn. For example, move 40h, R5. The content of the R5 register are copied into the 40h memory location. The next instruction syntax is move direct, direct. For example, move 50h, 30h. That means whatever the data which is placed at the 30h memory location is copied into the 50h memory location. The next syntax is move direct, immediate data. For example, move 50h, hash 25h. That means this 25h data is copied into the 50h memory location. The next instruction is move direct @RI. For example, move 60h @RI @R1. That means whatever the data is pointed by this register R1 is copied into the 60h memory location. The fourth case is destination is indirect address held by the register RI. The syntax is move @RI, A. For example, move @R0, A. That means the content of the accumulator is copied at the memory location which is pointed by the register R0. The next syntax is move @RI, direct. For example, move @R0, 30h. That means whatever the data is stored in 30h memory location is copied into the location which is pointed by the register R0. The next instruction is move @RI, immediate data. That means its example is move @R1, hash 25h. That is, this 25h data is copied into the memory location which is pointed by the register R1. I hope you all understand all the four cases of the move instruction. The next instruction is move DPTR, hash data 16. Its function is load the data pointer, and in this instruction no any flags is affected. It loads the 16-bit DPTR register with 16-bit immediate value. For example, move DPTR, hash 1243h. After this instruction, the 1243h directly loaded into the DPTR register. We know that DPTR is a 16-bit register which is divided into two 8-bit registers. First one is DPH and second one is DPL. That means 1 2 is stored into the high byte and 4 3 is stored into the low byte. That means after the execution of this instruction we have the value DPH 12h, DPH is equal to 12h and DPL is equal to 43h. I hope you all understand the concept. The next instruction is internal RAM instruction, push instruction. This push instruction is already studied in the stack organization point. Let's see once again. Its instruction syntax is push direct. The function is pushed onto the stack. No any flags is affected in this instruction. It copies the indicated byte onto the stack and stack pointer is incremented by 1. This instruction only supports direct addressing modes, that is push A or push 3 R3 is invalid. Okay, for example, push 0E0H, that means push accumulator into 0E0H stack location. That means whatever the content in the accumulator is stored into the 0E0H memory location. The opposite instruction of the push is pop instruction. Its syntax is pop direct. The function is pop onto the stack. It copies the byte pointed by SP to the location where direct address is given in the instruction. For example, this instruction only supports direct addressing modes, that is pop A or pop R3 is invalid. For example, pop 0E0H. That means it pops the content of the 0E0H stack location to the accumulator. After this instruction executed, whatever the content in the E0H memory location is loaded into the accumulator, and in this instruction the stack pointer is decremented by 1. Okay, the next internal RAM instruction is exchange instruction. Its syntax is XCH A, byte. Its function is exchange accumulator with byte variable. It exchanges the content of the register A and source byte. For example, XCH A, RN. For example, XCH A, R3. That means after this instruction, the content of the R3 now is into accumulator, and the content of the accumulator is in the R3 register. The next addressing is direct addressing XCH A, direct. For example, XCH A, 30H. After execution of this instruction, whatever the content in the 30H memory location is now into accumulator, and the accumulator content is at the 30H memory location. The next addressing mode is indirect addressing mode. Its syntax is XCH A, @RI. That means whatever the data is pointed by this RI register is exchanged with the accumulator. For example, XCH A, @R1. That means after this execution of this instruction, the data which is pointed by this R1 register is now in the accumulator, and the accumulator contents is in this memory location which is pointed by the R1 register. I hope you all understand. The next instruction is XCHD A, @RI. XCHD, here D stands for the digits. Its function is it exchanges the digits. It only exchanges the lower nibble of accumulator with lower nibble of RAM location pointed by RI. That means after the execution of this instruction, only lower nibble or the lower 4 bits are get exchanged, while the upper 4 bits are remain as it is. For example, here A0 to 3 is exchanged with RI0 to 3. Now the next type of instruction is external RAM instruction. When we use the external RAM instruction, then we use X with move instruction. Hence its instruction syntax becomes MoveX destination byte, source byte. Its function is move external. No flag affected in this instruction. One important thing is here that whenever we use external RAM instruction, we have to add X into the move instruction. Okay, it transfers data between external RAM memory and accumulator. As it is for external RAM, X is appended to move instruction. Okay, its syntax is MoveX A, @DPTR. That means whatever the data which is pointed by this DPTR register is copied into the accumulator. The next instruction is MoveX @DPTR, A. For example, MoveX @DPTR, A. That means in this case the data in the accumulator is moved into the memory location, the external memory location which is pointed by this DPTR register. The next instruction is MoveX A, @RI. That means whatever the data is pointed by this RI register or this R1 register is copied into the accumulator. Similarly, we can say about this instruction MoveX @RI, A. That means MoveX @R0, A. The content of the accumulator is copied into the memory location which is pointed by the register R0. I hope you all understand the MoveX instruction. Now, the third type of instruction is program code memory instructions. It uses MoveC instruction as mnemonic. MoveC destination byte, source byte. Its function is move code byte. It moves a byte of data located in the program code memory or ROM into the register A. Its instruction is used in the indexed addressing mode. The first instruction is move A @A plus DPTR. The next instruction is move C A, @A plus PC. Here the address is used in indexed addressing mode, and this index is formed by adding accumulator into the DPTR and in program counter. I hope you all understand all the three types of data transfer group instruction. Let's see once again internal RAM instruction. To access the internal RAM memories, we use move instruction. To access the external RAM memory, we use MoveX instruction, and to access the external RAM program code memory or ROM, we use MoveC instruction. I hope you all understand the basic difference between these three types. Thank you.